So the number of bolts we get around 5.7. So let us provide 6 bolts per row. Now we have 6 bolts and the pitch of it is 60 mm. So we will have something like this, and also we know that the edge distance is 40 mm. So 40 and 40 on either side, and each of this is 60. This total of 40 into 2 plus 60 into 5 is 340 mm. So this is 340. The flange width of the ISHB and the ISHT is the same, that is 150 mm. So this thing here is the ISHT and this is the ISHB 300. Two rows of 6 bolts of M24. So H is 340 mm as calculated, and to find the neutral axis we know it has to be it's assumed as H by 7, or 1/7 of the entire height, and this is 48.57 mm. Okay, this is what I had drawn in the previous lecture. So we know that the top bolts are in tension and the bottom bolts are in compression. So we have found out this value as 48.57. So this distance is 48.57, the neutral axis. Okay. So if we go back to this diagram, we know that the neutral axis is somewhere along this line here. I will say NA, neutral axis. And now we need to find out the Y, that is the distance for each set of bolt from the neutral axis. Okay, so we need to find out this distance, and this distance. So let me first find out the Y of the second bolt, that is this one. Let me number them. This is the first set, second set, third, fourth, fifth and sixth. So I'm talking about this as one set. 1, 2, 3, 4, 5 and 6. So the Y for second bolt okay will be equal to, this is 40 plus 60. So I'm calculating this entire length and I am minusing this length. So it is 40 plus 60 minus 48.57, and this is 51.43 mm. This works out to be 51.43 mm. Similarly, I find out for the other sets of bolt, I am tabulating it to 3, 4, 5 and 6. And this is Y in mm. So this we already found out, 51.43. Third one is 111.43. Then it is 171.43, 231.43 and 291.43. So we found out all these values. Now since there are two rows of bolts, we need to find out summation y, and summation y is the total of all these numbers here, 51.43, 111 and so on. This works out to be 857.15 mm. Now we have two rows of bolts, so summation y will be 857.15 into 2. Okay, and we also need to find out summation y square. So it is 2 into 857 square is 182,941 mm square. Total moment resisted by the bolts is given by m dash. This formula was discussed before. Substituting all the values, we get 31.2577 into 10 to the power 6 Newton mm. Next we need to calculate the tensile force TB, and this is given by m dash yi upon summation of yi square. This force is calculated in the extreme bolt. Seven into 10 to the power 6, and yi square is 2 into 18941. Yi is the extreme bolt, so we use this value here, 291.43 into 291.43, which is equal to 24897 Newton. The direct shear force is denoted by VSB, and it is given by P. In terms of Newton, it is multiplied by 1000, P into N. P divided by N. So this is P and this is N, is the number of bolts. So there are two rows of 6 bolts, and this is 50,000 Newton. Now we need to check by interaction formula. We get VSB upon VDB, what we had calculated before is 65192, plus TB, which is 24897 upon the design tensile strength. Okay, so this is a formula we have used here, VSB upon VDB the whole square plus TB upon TDB the whole square. Okay, when we calculate this, we get 0.652, which is lesser than 1. Hence we can say that the bolts are safe. The bolts are safe. With this problem, you are expected to find out the number of bolts, arrange them, check for the interaction formula, and most importantly, a neat diagram which indicates the pitch, the edge distance, and the sections. Sections in the sense, you have IS HT 75, you have IS HB 300. So the diagram of yours has to be neatly labeled. With this, we finish the example problem. Thank you.